Hi and welcome to the second video on trig equations. For this video I'm going to look at the idea of general solutions. Basically what this means is that for sine, cos and tan equations you can actually get an infinite number of answers because it's like the unit circle, they just keep cycling through and you can get an infinite number of answers to this. So what we give is a general solution to tell you what the answers would be, and then if you plug in your specific domain you'll get the actual answers that you're intending. But we'll leave them in general solutions for this. As you can see, I've used the same steps that I've got that I had in the other one. The only thing is I don't look at the domain. I don't worry about this because there is no domain. It's a general solution. So what I do is largely the same kind of process as before. So sine theta equals 1 on root 2. That's the equation I've got. I identified my base angle by using my triangle, and I found out that that was pi and 4. So then I go, I need to know what the answers are for this, and I say that the answers would be either they're both positive, so that's in the first quadrant and the second quadrant. So it's pi and 4 and pi minus pi and 4, or 3 pi and 4 if you like. So what I do is then I'd say, okay, this happens every single time around a circle. It's not just in that circle, it's not just pi and 4, it's actually pi and 4 plus a full rotation around the circle. And 3 pi and 4 and a full rotation around the circle. And a full rotation backwards around the circle as well. So I say that theta equals pi and 4 and see 2 pi is once around a circle. But if I put this n value in here, that means that I can go any number of times around a circle. I could go once around a circle, twice around a circle, and that can either be positive or negative. So what this n means, n is any number, any whole number. It could be 0, it could be -1, +1, or any negative number, any positive number, any whole numbers we're looking at. And I also do 3 pi on 4 plus any number of times around a circle as well. As long as I end up in that exact same position, it doesn't matter whether I go 6 times around a circle or 5 times around the circle. If I end up in the same position, I will get the same ratio or the same y value, if in this case, because it's dealing with sine. Now, one thing that you do have to have in order to get full marks in this, obviously you have to have the solutions with this 2n pi, and there's other ways of writing this, by the way, but this is just the way that I've gone with it at the moment. You must have n is an element of z. If you don't have this, you'll lose a mark. Okay, because you can't just chuck in a random letter, because we don't know what that letter means. We don't understand if you guys know what you're talking about. So you have to put in this n is an element of z. Z means whole numbers, or whole integers. So whole integers, there's no such thing as a non-whole integer. Integers are either positive or negative. Okay, so you must have that in, otherwise you won't get a mark for it. You could also write down n is whole numbers, and you could give some examples: 0, plus minus 1, plus minus 2. That would be okay. You just have to explain what the n is. Okay, I'll move on to the second example. Cos 2 theta equals -√3 on 2. Now, using my triangles, I found the base angle, and the base angle was pi on 6. You can go and have a look at that if you would like to. And then I start my process of elimination. So not elimination. I start my process of working out, the answer. So 2 theta this time equals 5 pi and 6. Whoops, because it's in the second and third quadrant, because it's negative. So 5 pi and 6 and 7 pi and 6, and each time around the circle, so plus 2n pi. But then I need to divide everything by 2, because it's 2 theta, I want only theta. So I have to literally divide everything by 2. So I do 5 pi over 6 divided by 2, which becomes 5 pi over 12. But I also have to do this 2n pi divided by 2 as well to make it n pi. So it's no use just chucking plus 2n pi right at the end. You have to do it before you do all these other things involved in it. You only need to change this 2n pi if you're dividing or multiplying something. You don't have to do anything when it's when adding or subtracting. If it was 2 theta plus a half, you wouldn't need to minus a half from the 2n pi, because it's just saying once around a circle. You wouldn't go once around a circle and then move it to the left, because that's what you've already done to this one over here. I hope that makes sense. If it doesn't, I guess you can ask me about it a little bit, or when that question comes up, you can have a look at that one. Okay, that one's not going to rub out. So there we go. It's all gone. So I end up getting 5 pi and 12 and 7 pi and 12 plus n pi, and n is an element of z. Okay. Now, the only other thing I want to do is look at the tan. Tan is a little bit different. You can work it out exactly the same way, but it also works out to be a little bit different as well. So tan theta equals 1. I've just gone for a fairly simple one. The base angle being pi on 4. So I write down my answers. That's in the first and the third quadrant. So pi on 4 and 5 pi on 4. And each time around a circle, plus 2n pi, plus 2n pi. It's the same as before. N is an element of z. And that would be the answer. That's correct as an answer. There's nothing wrong with that. But I guess what you could do is you could actually notice that if I start from here and go once around a circle, I'm going to end up over here. Sorry, halfway around a circle, I'm going to end up over here. And then if I do that again and go halfway around a circle, I'm going to end up over there. And then halfway around a circle, halfway around a circle. That's always true for tan. It's always true if you go halfway around a circle, you'll get the other answer. So around a circle, I can't do two things at once. So I mean, what I've written here is absolutely true. There's nothing wrong with that. But I could have also written as this. I could also write pi on 4 plus n pi. Because n pi is just just halfway around a circle. And check this out, if n is 1, I'll get pi on 4 plus pi, which is 5 pi on 4. So I'll actually get both answers in one. So with tan, you actually only really need to have one answer, as long as you're adding half a circle, or the whole period of tan around each time. There's a bunch of reasons for that, but it doesn't really bother me whether you do this one or this one. Both are acceptable as long as you're getting them consistently right, and as long as you can identify them both if it was, say, a multiple choice question. Okay, so for sine and cos, you'll always get two answers, except for the ones, I guess, around the edges. It's only possible to get one answer around the edges. But for tan, you might only get one, and that's completely acceptable as well. So hopefully that's helped a little bit clear up general solutions, because I know that they can be a little bit tricky sometimes. But have a go at them and let me know if you need any help. Thanks.